Okay, so for day 3, it's just a continuation of day 2, but I'm just going to step it up a little bit. So what I want you to see, what you learned before was that when it was a little exponent, you made it big. And in the previous day, I think I said, okay, just accept it. But what I want you to see now is the justification for why it exists. So I want you to see how I split it up step by step. So let me zoom in a little bit. If you look here, 64 to the third means 64 times 64 times 64. Then if you break it down even more, remember when you're adding logs, it means you're multiplying. So if you're multiplying, it means you're adding. So it's like backwards distribution. So it's log 64 plus log 64 plus log 64. And then when you jump to the next step, how many do you actually see? 3. Now, do I need you to show all of this? No. I'm okay with you going straight from here to here. But what I thought was important is understanding the justification of the reason why. All right? So let's do this next problem. So what is it I just taught you? Whenever you see a little exponent, make it big. Next thing I taught you, remember when there was base, this number also needs to match. So I'm going to go 2 log 3, 3. 3 to the what is 81? I don't know. Let's look at our calculator. So I turn it on. Let's go, oops, you can't see that. Let's go 3 to the 5th. No. 3 to the 4th. Yay. Some of you already knew that. So there's a 4. But how this is different is I have another exponent. So now that exponent also gets big. So this gets brought down. That 4 gets big. And I remember log 3 is 1. 2 times 4 times 1, 8. Okay. Next problem. Little guy, big. Okay. Now that I did that, the goal is, since this is a 5, make this a 5. Now I have to figure out 1/5 is 5 to the what power? Some of you know that's -1. If you're not sure that it's -1, let me show you. So in the calculator, let me zoom out just a little bit. If I go 5 to the -1, it tells me 0.2. Now if I go second PRB, sometimes it works and sometimes it doesn't. It's super annoying. Okay, let's try this. 0.2, second PRB. It tells me 1/5. And there you go. There's my 1/5. So now I know 5 to the -1 works. Take the little exponent, make it big. Oops, I don't need to write that because log 5 is 1. And then this is -3. Okay? Now, this is in base 3. This is in base 5. If you don't see a base, remember that means imaginary base 10. What do? Little, big. Now the great thing is log 10 is 1. 4 times 1 is 4. So the issue on that one is knowing the base. Let's go to the next one. Make the little big. Now that you understand the game, I'm okay with you just going straight to making that a 2, and you know that's 2 to the -1. If you understand what I did, you can do that. If you need to write log 2 1/2 and then the next step get there, that's fine. Now make this big. Log 2 is 1, -5. Okay? All right. So that just stepped up what you did yesterday a little bit. Let's go to the next one. What this rule is saying is that if your base is the same as this number, it's equal to that value. Well, that's something we already knew. But let's change it a little bit. If you look, all of this is an exponent, so all of it needs to get big. And now log 8 is 1. And anything times itself, and you're done. You need to put it in parentheses. If you don't, and you leave it 3x, let me move this up, plus 1 log 8, what you're saying is only the 1's multiplied to the log 8, and it's all of it's multiplied to the log 8. Right? Same thing for the next one. Little, big, boom, 1. And you're out. Now, this one's going to seem a little bit different because this is big. But the problem is if you put a 2 here, then they're not close to each other to make it work. But you know, like when you multiply, if I had 6 times 2, that's the same thing as 2 times 6. So instead of putting it in the back, I'm going to put it in the front. And now 2 log 2 is 1 times 27 is 27. Same thing here. Little big. Keep the 8x in parentheses, otherwise it looks like log 2 times x. Now if I keep the 2 and I put it on the back, it's not connected to the log 2. But if I put all of that in the front, now 2 log 2 is 1 times 8x is 8x. Okay, let's go to the next page. All right, let's look at number 1. Now the problem with number 1 is that I can't make 27 turn into a 9. Now, I know some of you say you can go 9 times 3, and you think, oh, well, then there's 1 and 1 times 3. But the problem is the 3 is also with the log 9. Remember the rules, this would mean log 9, 9 plus log 9, 3. So you can't do that. But if it said log 9, 9 cubed, now, since that's little, big, and that would be a 3. So the problem is now none of the rules work. It reminds me of what happened here in that first lesson when I said 2 to the x equals 9. All these other ones you could figure out, no problem. But if you can't figure out the answer, so like if I was going to change this to log form, base 2, 9 equals x, I can't change that 9. So there's a rule that says if you can't change it to make them match, you take the log of the answer over the log of the base. So I'm going to go the log of the answer over the log of the base. And what that means is, okay, if you're in base 9, I can't find the answer. But if I'm in imaginary base 10, I can manipulate it so that I can get the answer. So then what I'm going to do is I'm going to pick up my calculator, and I'm going to go log 27 parentheses divided by log 9. Oops, I didn't want that to be. Let me get a different one. Sorry, log 27 divided by log 9. Ah, darn it. Okay, maybe third time's the charm. For some reason, they're all rounding now. If this one ends up rounding, then I guess we're good. Well, I guess that's the answer, so let's see. Some of you don't understand what I'm saying right now, but you eventually will. Okay, so I get 1.50. So there's your answer. Done. So now, I can't change the 16 to an 8, so I go log 16 over log 8. And you can do this in your on your cell phone as well. Now this time, I have repeating decimals. If you remember, I want you to round the nearest hundredth. So it's like dollar and cents. So it's $1.33. Let's go to the next one. I can't change the 9 to a 4. So log 9 over log 4. Let's be honest, once you get the game, it's a 50% shot. But I remember the bigger number is on top. So I'm going to go log 9, divided by log 4. And I get 158. The 4 doesn't round up, so it's 158. Or 1 and 58/100ths. Now, you don't always have to round to the nearest hundredth, but for me as a teacher, that's what I like. So if another teacher likes you rounding to the nearest tenth, that's what you've got to do. If they want you to not round, if they want you to round to the nearest thousandths, whatever they want is what you have to do. But since me as your teacher want you to round to that, let's get good at it. So I get 226, and I don't round up, so I'm good to go. All right. I need you to be solid in this because once I get here, which is going to be Wednesday, it steps it up big time. So with that being said, I want you to be 100% clear what you need to have done before walking into my class on Wednesday. This. You need to be solid at this or you will cry here.